Perfect. Okay, 201, that's my magic hour. Okay, so I want to try to cover over a majority, if not all, of events. Actually, let me change this instead of event. Let's just call this JavaScript events. Okay, so over the course of this lecture, I want to talk about the event loop in JavaScript, or especially inside the browser. I want to talk about the different types of events that there are. I want to talk about listeners and handlers. I want to talk about what the event object is and the concept of bubbling and capturing events and event delegation. Then we'll move on to talking about how we can create our own custom events that we could dispatch into the event loop. And then we'll look specifically at mouse events, keyboard events. I have a section for touch events, but I haven't really filled it in because it's pretty similar to the previous two. You just look up the API. Then I'll talk about the document events. Form and input events, I think, is super critical. And then we'll talk about scheduled events or timed events. And then we're done with the event system. So the first thing, I think we talked about this a little bit last lecture, is when we're designing a GUI, a graphic user interface, and that's what the browser is. That's what most applications that end users will interface with are going to be graphic user interfaces. They all have a very similar design pattern. Effectively, you have this event loop. So the browser JavaScript execution flow, and this works in Node as well as the browsers, execute an event loop. The event loop is based around a very simple concept. It's an endless loop where the JavaScript engine waits for a task and executes those tasks in the order that it receives them. And when it's not executing tasks, it sleeps while waiting for more tasks. So the general algorithm looks like this. While there are tasks, execute them, starting with the oldest, and then sleep until a task appears, and then you go back to step one. So that's pretty much the formulation on how something happens as you browse some HTML document. So most of the time, JavaScript's actually not doing anything in the background unless we have something that's in the event loop. Okay, so let's look at some examples of tasks. So when an external script is linked to your HTML document, and when it initially loads up, all the tasks that are defined within inside that script will execute. So that triggers. So there's essentially a load event that occurs when your script is imported into the DOM, and it executes whatever instructions are at the line level. And then it actually builds everything from the global object and defines everything that needs to happen in the JavaScript runtime environment. Okay, what are other examples of events? Well, when the user moves the mouse, some task, the task is to dispatch a mouse move event inside of the event system, and then maybe execute any handlers that are listening to a mouse move event. Other examples of what happens with the event loop is if we have anything that's scheduled in terms of time, we can set, say for instance, set timeout, set interval, or like to request an animation frame. Then those tasks will then go ahead and also run their callback function. So these are all different examples of how the event loop is used to execute our JavaScript code. So tasks are set, the engine handles them, then waits for more tasks, and in between tasks, it just sleeps. And here's just a little graphic to illustrate that. Okay, so important things you should know about the event loop. It's single-threaded. So rendering never happens while the engine executes a task. It doesn't matter if the task takes a long time, changes to the DOM are painted only after a task is complete. So if a task takes too long, and then the browser can't do any other tasks, such as processing user events, after a while, you might have seen this happen before. After a while, you might get an alert from your browser that says that a page is unresponsive, suggesting that you killed the task along with the whole page. And so that happens when there's usually complex calculations, or when there's some kind of flaw in logic, like an infinite loop. So this is important to know. If you're going to do heavy computational tasks, you might want to avoid doing it on your main thread that actually paints and renders your viewport. If, say, for instance, you're going to do some machine learning, which isn't as silly as it sounds. When I went through the machine learning class, I did all of my implementations in JavaScript. You can use web workers to run your like a genetic algorithm in the background. That might take huge volumes of computations, but doesn't affect the responsiveness of your front end viewport. Okay, let's talk about the different types of events that there are. So an event is a signal that to indicate that something has occurred or happened. So all DOM nodes generate such events, but events are not limited to our DOM. So we can also get mouse events, we can get keyboard events, we can get events from forms, we can get events from the document object or the document that's getting loaded by the browser. We can even get CSS events based off of animations. So this is just a quick preview of things we will be covering in this lab. So we will go into detail on the mouse events like click and context menu and mouse over, mouse out, mouse down, mouse up, and mouse. These are all different actions that occur when the mouse is used. And keyboards are pretty easy. It's just key up, key down. You've seen this one in the platformer. I don't think we've done anything really with a mouse yet. And then for a form, we can submit a form typically to a web server, and we can check to see what field inside the form is focused. And then we can check to see if something's been loaded or not. Okay. So let's talk about the listeners and the handlers. So in order to react to events, we can assign a handler. So a function that runs, so a handler is essentially just a function that runs in case an event actually occurs. So this is how we respond to events. We are able to register a listener to the event dispatch system. When an event is dispatched, it checks to see what it's been registered with, and then it'll go ahead and invoke the callback function that was assigned to that event. And so here's probably the first time we formally used the word callback function, although we've seen the concept of a callback function with some of the functions that we declared in data structures and in our JavaScript basics lectures. It's just the concept of callback function is just a function that's passed to another function as an argument. So whenever you have the function that's being passed is a callback function, and the concept is that that function's being passed because it's going to get invoked in some future state of your application. And so there are certain criteria that might occur for that callback function to get invoked. So for us, it's in response to an event, but there might be other reasons why a callback function is passed to some other function. And if you might recall, the functions that receive these callback functions are called higher order functions, as opposed to first order functions which take in values. Okay, so let's talk about how we can assign event handlers into the event system. So first, let's talk about using an HTML-centric approach. We can take a handler and we can set it in HTML with an attribute name of on and then whatever the actual event is called. So for instance, if I want to assign a click, so if I want to listen for a click event and then assign a handler, an event handler, to do something in response to that click event, I can, inside my HTML code right here, I have an input. This input has the value of click me. You'll see it's a type button. So I have a button that says click me, and on a click event, so it's going to listen. And so when a when a click event occurs, I will respond by console logging click. So we can actually just do what we did last time. It seems this was a pretty popular thing. Be able to jump into just a browser console, and we will do document.write, and I will paste this code here. So this is just the HTML. So when I go and submit that, you'll see I now render my HTML. I can check the elements just like before. Perfect. And when I click it, you see it will now respond to the click event by going to my console here and displaying a click. And each time I click it, notice it gives me a new number illustrating the number of times. So console is nice. It tries to minimize the vertical space when you have redundant messages. Okay, so typically though, we don't want to put all of our code. So right here, we took our code and we passed it as a string. And so that works, but typically you need to do more than one line of code in response to a click event or whatever the event is. So more common is the theme, whether you do this via HTML or whether you do this via JavaScript, is to create a function. Say, for instance, here we have a function, and you assign that function in the onClick attribute in your HTML, you assign the invocation of that function. So this is going to be a little bit different. So if you're assigning your event handlers in the HTML attributes, then you're actually invoking the function, right? We're actually inside, and we're doing that inside of text, because remember, this is not in the JavaScript runtime environment. This is in the HTML document itself. So when this gets parsed by the browser, it'll read this string, which is an invocation, and it actually sets that up almost like an event object. So it says, oh, in response to an onClick, I will execute this string as JavaScript code. So when we do this in JavaScript, we'll pass the actual function object as opposed to doing a string that contains an invocation. Okay, so let's look at this. Let's move on away from the HTML and look at doing the same thing, assigning the onClick attribute, but instead of from the HTML, like we defined in here, let's do it actually from the JavaScript. So here, from the JavaScript DOM object, from the HTML object, I can access the attribute onClick, just like I could any other property from the HTML object that we have from the document object model, and I can then assign it a callback function. So here, I'll do the same thing. I'll create an input that is a button. I'll give it the ID of BTN, so I have access to it inside of my JavaScript runtime environment. I'll have it say click me, and it's type button. Inside of the actual JavaScript code, I will dereference the JavaScript object that represents that button. I will assign to it an onClick, or I'll access its onClick property, and then I will assign to it a callback function that will just go ahead and do the same thing, console.log.click. And let's run this and see if we don't get the same behavior we got before. So let me go here, let's go to document.write, and we will pass this right in there. Okay, perfect. So if I go in here, yep, I have a script, I have my input, so that is as per expected. If I click, yep, same behavior. And again, just the big difference here is that if I access the onClick property in JavaScript, I have to actually assign a callback function. I provide a function object, whereas if I do it in HTML, I'm passing a string that does the invocation on the function that I intend to invoke. Okay, so yeah, but yeah, that's doing the same thing. Okay, so the next big thing that we should kind of talk about is what is the reference of this when it's clicked, when it's dereferenced inside of a callback function that's been passed to an event handler. So why don't we see this? So here we just did the same thing. We're going to create an input element that is a button that says click me, but this time when we click it, we're going to console log what the this pointer is pointing to. So we know if we ever pass a function that uses the this keyword, what it's going to dereference without binding it. And we already talked about binding a reference of this to the function object as we pass it around, I think in a previous lecture. And please let me know in the comments or the chat channel if you recall that or not, or just to verify that. I'll check when I've done this example. Just want to. It's okay, document.write, and let me pass this. Okay, so we will write that into the DOM. Okay, there we go. And so here, when I click on the button, it's going to give me a reference to the actual HTML element that was the target of the event. See, so I clicked on that button, and so that's the reference I get back. So please keep that in mind when you pass your when you pass a reference to a function. If you don't bind the this, if you don't bind a reference to what the this is referring to the function object, then it defaults to using this on the HTML element that triggers the event. That can definitely lead to errors in code. Without real, especially if you're passing things like class methods into an event handler. Okay, so possible mistakes, the one I just mentioned. Other possible mistakes are when you are supposed to assign a function object as opposed to an invocation to that function object. So remember, in JavaScript, you want to assign the function object. You don't want to assign the invocation on that function. Two different things. And I know it can be confusing because it appears to be done one way in HTML as opposed to another way in JavaScript. But in actuality, in HTML, it's really the same thing because we're not invoking the function. We're passing a string that's invoking the function. And that string isn't parsed and executed until a click occurs. So it's a HTML way of defining a callback function. Okay, there are better ways to define event listeners and event handlers, though, or to register an event handler to listen for an event, and that is the Add Event Listener button. And so you should be super familiar with this one, simply because this is the one that I use in the lab. And so this is the one you typically want to use for several reasons. And the most important of which is that the Add Event Listener allows us to go ahead and register multiple callback functions to respond to one particular event. So one of the deficiencies about using, even in JavaScript, the on event property of the object that you're trying to register an event on is, or to respond to an event, is that you can only assign one callback function. So if I did this first callback function and then tried to do a second callback function because there was two things I had to do in the response to a click event, I would not be able to do that. I'd have to redefine my function to be able to handle both cases, in other words. So instead of having to do that, we can just use Add Event Listener. Did I not have a demo over that? I thought I did. Guess not. And one nice thing about being using the Add Event Listener is it allows us to also dynamically remove events, event listeners as well. So on the element, we can also access the Remove Event Listener. We can pass it the type of event, such as a click event, and then we can pass it a reference to the callback function, and it will unregister that callback function from the event dispatcher. Okay, yeah, and here's some examples that I put together. So in this example, I just have some HTML that's going to create a button. It says click me. We'll call it ID LM, short for element. I'll create two callback functions, a handler 1 and a handler 2, and then I'll use this Add Event Listener to listen for a click event, and in response to a click event, I'll actually pass it both these callback functions. So when I click this button, I should have both these callback functions triggered. Both of them should go ahead and get invoked. So let's go ahead, clear this. Let's go to document.write. Okay, let's go into here. And okay, got our code. Let's hit enter. Okay, got my click event. Let me check my elements. Got my callback functions. Perfect. Okay, I'm going to hit my click me. Notice one button triggers a hello from handler 1 and a hello from handler 2. That's exactly what the two callback functions do. Hello from 1, hello from 2. So that offers great amounts of flexibility. Okay, the next thing I want to talk about in terms of the event system is the event object. So every time a event occurs and the dispatcher sees that that event was being listened for by a callback function, by default, JavaScript passes an event object to that callback function. And that event object has a lot of properties associated to what that particular event was. So let's see what's inside of the event object. One of the beautiful things about DevTools is we can just console log the event object that gets passed into our function. So here on a click event, so I'll just have this button here. I'll access it in my JavaScript. On a click event, I'm going to look for that event object that always gets passed when an event dispatcher invokes a callback function. It passes that as a parameter. So I will cite that as a parameter I'm looking for. And then, in fact, if you have a function that requires parameters, understand it's only ever going to get past the event object. So if there's a callback function that you do need parameters for, you might have to wrap it into another callback function that doesn't have any parameters, and you define the parameters inside the body of your callback function. So do keep that in mind, is that you can't create a callback function that has parameters that aren't the event object. So on a callback function, it only expects that one parameter of an event object. But here we'll actually capture this event object. We'll get it passed in, and we'll just console log this to see what it looks like. Okay, so let's see this. Let's grab this. Let's mosey on over into our browser here. Let's just go into document. Write this to our DOM. Perfect. Okay. So I got this button, and so when I click it, an event is dispatched, and then it gets handled by that callback function, and here it is. So I can actually see the event that occurred was a mouse event. Okay, and then I can unpack it. I can see this mouse event. This mouse event has bubbles. It has a client X and a client Y, which we learned about in the DOM. That's positioning. It has a page X and a page Y. It has a screen X and a screen Y. It has an X and a Y. There's a lot of data in here that you have access to and could potentially be useful for making decisions on how you're going to respond to this event. I think there should also be event type. Let's see. Yeah, you can see there's a type here. So type was a click event. Target, so here, related target was null. Let's see, is there a target? Yeah, and the target was, look at this, the target is an input element with the ID of elem. So it even lets me know what it gives me a timestamp of when that event occurred. So you can see lots and lots and lots of really cool pieces of information available to us for that event object. Okay, so I kind of walked through some of these. So if some of the key ones that are worth looking at, type tells you what type of event that the handler got invoked by. Current target shows you the HTML element that essentially responded to that event, or and then client X and client Y are the window coordinates of the cursor when the event occurred. So far, we saw how we could add events by just assigning a callback function to our event dispatcher. However, we can also pass an object to handle events for us. So one nice thing about passing an object is that objects can maintain state as opposed to, as well as just being able to be invoked for some kind of action. So in this instance, the one requirement is that the object you pass to be an object handler to handle your events is that it has to have a method called handle event. Because implicitly, what JavaScript's event dispatcher is looking for is to be able to invoke a handle event. So when we pass it a callback function, what it's doing internally is creating an anonymous object that binds the callback function as the handle event function. If we pass it our own function, as long as it has a handle event function, it will invoke it from the custom object we pass it. It's a say function event object. So we can pass it our own object, provided it has a handle event function or method, and it will invoke it from there, as opposed to just passing it a reference to a function object. So in this example, I have a button. I'll give it the ID of LM, short for element. And here I'll create a object. And on this object, I will assign a property called handle event, which is just going to be a function that will take the event object and console log its type. And then I will register this on this element an event listener for a click with that object that has the handle event method. And we can actually see this work in practice and prove that this is working code. I think that's the thing I like most about just copy pasting the code into here to illustrate what's happening, is the fact that it all works and is easily verifiable and testable. Okay, so let's go ahead and write that to the DOM, and if I hit click me, notice it does click. Yep. So that's just an example that I can either pass a callback function to add event listener, or I can pass an object that has a handle event function. So if you create custom objects, you can just pass them to your event handler, provided you have that method name. Okay, let's see here. So as we can see, when we add an event listener and it receives an object as the handler, it calls the object handle event. So just like this. And so the nice thing about this is when we create a class, let's say menu, that has a handle event method, we can actually look for multiple events. Because keep in mind, the event object has a property called type. So inside this handle event, we could check on different cases. If the case were a mouse down event, we could do one thing. If it was a mouse up event, we could do something else. And then we can register that one object to multiple events. And then mutate the state of the object based off of what event has been triggered by the event dispatcher. Okay, so the method handle event does not have to do all the jobs itself, right? We can also create helper methods to do the same. So here, you can imagine this handle event method could start to look really big if we just put a giant switch statement with all the code for each particular use case. So what's nicer and cleaner is if you're going to build some kind of object that's going to get mutated by a variety of events, to have a set of helper methods that represent what you do for each event. And then inside your handle event, you can then go ahead and then invoke the particular sub method, the helper method that makes the most sense. So you can still have your switch statement in here. You just don't put your internal logic for what happens for each event. Again, I think this is just kind of basic programming practices. So I won't spend too much time demoing that. Okay, so that's it for the event object. Let's talk about what it means for events to bubble, the bubbling phase, and the capturing phase of events. So far, we talked about what are events, how do we listen for events from the event loop via the event dispatcher, how do we handle an event when it actually occurs, what is the event object that gets passed to the callback function. The next is what are the phases that occur in the event loop for capturing, for handling and listening to events, or listening and then handling events. So that's this concept of bubbling and capturing. Okay, so the bubbling is a principle. It's pretty simple. When an event happens on an element, it first runs the handlers on it, then on its parent, then all the way up to all its other ancestors. So the concept here is it's called bubbling because events bubble from the inner element up through the parents, like water, like bubbles appear in water, right? It starts at the very bottom, and then the bubble propagates all the way to the surface of the water until it's expelled out. So just like a boiling pot of water. So let's take a look at this. Let's say we have three nested elements, a form element that then has a child element, which is a div, which then has a child element, which is a paragraph. And we put a handler on each one of those. So suppose I have this on-click handler that'll send an alert out if P is clicked, and then one for this div here on my div, and then one here on my form. If I were to click on the P, then because of the bubbling phase, it would also trigger the on-click on the div and also the form. So since that event occurred to one of its children, it occurs to all of the parents. And so that's, again, that concept of bubbling. So here on that P, then onto the div, then onto the form, and then actually onto the document object as well, if we had registered an event to the body. I think I do have an example of that in just a moment that we can actually see. So here, let's talk about event.targeting. So a handler on a parent element can always get the details about where it actually happened. The most deeply nested element that calls the event is called a target element, and it's accessible from the event object by event.target. So now let's differentiate between this object and the event.target. So this object, as you might recall, changes its reference quite frequently, depending on what object you're in. So it's not always the case that this will refer to the current element that you had generated the event on, whereas event target will always give the target element. So if you're looking to get the target of an event, use event.target, don't use this. And I'll prove this concept in just right now, in fact. So here, let's take a look at this code really quick. This is all sample code. Here I have my HTML. I have a head here. Inside my head is a style tag. I will style the form with a background color of green. I will style the div with a background color of blue. I will style the paragraph with the background color of red. In my body, I will go ahead and just give a statement, which we'll see when I go to render this. I'll define the form. I'll give an ID of form. I'll have the div, and then I'll have the paragraph. And then inside my script, I'll just go ahead and create an on-click that will go ahead and write to the document. So I'm actually doing a document write. I'll probably update that to console log to show what the target is and what the this is. Okay, so here, let's go here to let's refresh this. So we start anew. Let's go to document dot write, and let's go ahead and paste all that code. So now if I hit enter, bam, I have my style, I have my events right there, I have my event that's on my form, and I have my different colored div. So remember, this is the parent, this is a child to form, this is a child to div, which is then also a grandchild or an ancestor of form, or descendant of form. Form's an ancestor to the paragraph. So if I click on, so I can click anywhere on here. If I click on form, it shows that the target was form and the reference to this is form. Remember, I only have the one on click, right? I only set up a click on form. But since the form defines everything, an on-click event will get captured by form no matter if I clicked on form directly or any of its children, because any of its children are technically also form, right? So you kind of want to think of this as in a form of inheritance in the way that bubbling works. If I generate an event, it gets passed to all of its parents. So if I click on my div, so notice my target was div. So the event target actually gives me the actual element that it was target of, but this is going to reference the event listener that's currently being attached to the event dispatcher. And so that was the actual form element. And so again, if I hit the paragraph, you can see I can actually get the target paragraph, but the reference to this is on form because that's the object, the HTML object that the event handler, event listener was passed to. So we set up an event listener on form. So the reference is always going to be for this is going to be on for that. But I can access any of the actual children within form that got passed from the event object via its target property. I hope that makes sense. Okay, now for any reason you want to stop that bubbling, then you can just go ahead and on the event object, invoke a method that's called stop propagation. And that will prevent that bubbling effect from occurring. Does bubbling make sense in terms of this concept? I have a graphic, if it doesn't, that I'll show in just a moment. So let me show you this. Let's do document.write, and we'll take a look at what this is. I think we just did. Yeah, so this is, oh, it is, okay, I need to, must be, oh, I see, this is not designed very well for me to do this, so let's change this to this. Change this to this. Okay, perfect. Just breaking my string. Okay, so I have a button here, so let's take a look at what we have. So I have a button, and then I have an on-click setup on the body, which will alert that bubbling doesn't reach here. And when I click this button, the event that's getting passed to the button, we will tell it to stop propagation. So when I click, yeah, that alert never happens, right? And the reason why this alert that has been set up on the body doesn't happen is because we stopped it from bubbling up with the stop propagation on there. Okay, so let's actually look at what is happening here. Let's look at the 3 phases that happens for event propagation. So in phase 1, you have the capturing phase. This is where the event goes down the DOM element by element. So if you have a click event, that click goes essentially goes to check to see is there a dispatcher registered for the window or in the document, then the HTML, then body, tab, T-body, because all the way down until it finds the target of where that event actually occurred at. So let's say that that event occurred on this table cell, this piece of table data. Then that brings us to step 2, the target phase. The event reached the target element that actually triggered the event that had it dispatched to begin with. And then once we find the target, then we bubble back up. And so this is the bubbling phase where we're like, okay, is there a callback function for this event on this target? And then is there a callback function for this event on its parent? Is there a callback function on this event on its parent, 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 all the way up until you get to the global window object. And this is why if we set up a click event on the body, it'll go ahead and trigger no matter where you click on. I mean, also because it's been the target was the entire body. Okay, so let's talk about capturing. To catch an event on the capturing phase, we need to set the handler capture option to true. So there were 2 possible values of the capture option. So on the event handler, you can set up the event type, then you set the callback function, and then you can set up whether it should get captured or not. And if you capture an event, you can essentially, let's see, I can't show you what it looks like to capture the event. So when you capture event, when we set this to true, so we either set it true as a parameter here, or we can pass an anonymous object that has a property capture and then a Boolean value of true. And so what it means to capture event is that we respond to the event during the capture phase instead of the bubbling phase. So we actually have a little bit of control on when our callback function gets invoked. And so, well, actually, let's take a look at that in practice. And to prove that, I'll just run this small sample of code. Let's go to console. Let's go to document.write, and let's write out this. Perfect. Okay. So here, what am I doing? I'm first of all going to apply a style to the body and all of its elements. That will then go ahead and set a border of blue border 1 pixel. Then I'm going to create a form. I'll create a children inside of it. Oh, a child inside of it. That's a div. I'll create a child inside that div, which is a paragraph. And then I'm going to have the script that will iterate over all the elements inside the document. So I'll use a query selector all and just pass it the wildcard, the asterisk, that'll pull all the elements. And then for each element, I will add an event listener that will send an alert for the capturing phase. And then I will add an event listener for a click that will send an alert during the bubbling phase. So I just want to illustrate that we actually have 2 different mechanisms, and I want you to see the order of how these callback functions will get invoked when we submit this. So let me go into here. I'll click on the div, and here I have now notice what we want to see. I have the alert there, but what we want to see is this, right? Where we go downward and then upward again. So the capture face goes from the window object down, and bubbling goes from the actual target of the event back up. So here we could say, that's our HTML document. Yep. We captured the HTML, then we captured the body, then we captured the form, then we captured the div, then we captured the div, or bubbled from the div, then we bubbled from the form, then we bubbled from the body, and then we bubbled from the HTML, and then we're done. Perfect. So that is a good illustration of what's happening for our event propagation, how it goes down and then back up. And so the entire reason why we brought up even the concept of being able to capture and bubble is because it allows us a means of implementing one of the more powerful things, patterns, one of the more powerful patterns for event handling. And that's something called event delegation. And so the basic idea with event delegation is that if you have a lot of elements that are handled in a similar way, then instead of assigning a handler to each of them, you can put a single handler on their common ancestor. So again, if you think about it, this is a similar principle about how you use inheritance in object-oriented programming, right? Like if there's a lot of similar properties that multiple subclasses have, those attributes go into a superclass. So if there's a lot of similar events that get handled in a similar way, you handle those events in a parent element. And so just a quick example of this is, suppose that I have a menu that we will call, that will be a div. So I'll give the ID of menu, and you have 3 different buttons. A button that's for attack, a button that is for defend, and a button for flee. I will assign a data action attribute to these buttons. I could have, which is going to be accessible, you will see inside of my JavaScript code. So inside of my JavaScript code here, I'll create a class called menu in my constructor. I will just go ahead and pass it a menu HTML object that is a JavaScript object representing an HTML element. I will assign that as a instance variable, and then I will bind an onClick callback function So on my onClick function, which is defined inside of this class, again, and so I don't lose the reference of this, I will bind this attribute to onClick. So on a click, to use the event delegation, you can see here, I will get my action. So when an event occurs, I will grab the event action type. So on the target of the event, so event.target, it will have a data set attribute. Well, the data set attribute is defined by a data action property that is defined or attribute defined inside this HTML element. So the property, data set property in JavaScript, HTML attribute in my HTML. So I will grab the action from the data set. I will save that into a variable, and I will check for that action. I will invoke off of my instance a method. So my action is attack, defend, and flee. I will create a method called attack. I will create a method called defend. I will create a method called flee. So in response to this action, I can call any one of these alerts. So attack, defend, or flee. Let's actually see this in practice. But you can see this is essentially the design practice we're looking for event delegation. Okay, so I have these three buttons. If I hit attack, it invokes the attack. If I do defend, it invokes the defend. If I click the flee, it goes ahead and invokes the flee sub-method in all of those. So obviously the advantages of this is we don't need to write the code to assign a handler to each button. We just make a method and put it inside of our markup here, and then we handle it inside of our class. So much more organized and structured coding practices that make managing the state and even expanding this out in the future much easier. Okay, so we talked about event delegation, we talked about event propagation, we talked about listeners and handlers in the event loop. Let's get into the nitty-gritty and start talking about the different types of events. The first type of event are just custom events. I don't know if we'll use this very often, so I'm not going to spend too much time on it. Just understand that you have the flexibility to define your own events, and you can define what those events are called in the event dispatcher. So by default, there's a lot of pre-named event types that get that can be added to the event dispatcher, like click or a mouse over or key up or key down. So those are given to us. But if for some reason you want to take advantage of the event loop and add in your own labeled events, like let's say a foo event, you can do that. You can create an event object that has the type foo and then assign it a callback function, and then you can inject the foo into the dispatcher so that it then triggers the callback function. And so the syntax for that is, well, you just call the event constructor with a new event. You give it a property that's called type for the name of that event. The type of the event is what it'll be referred to. So for instance, we could call it click, but there's already one on there. We can also call like my event. Foo is the one that I typically like to use for example code. You also have options on whether this event is designed to bubble up during the bubble phase and whether this event can be cancelable or not. Cancelable events are, you can like override or prevent the default action of an event. Okay, and this is just an example of how we can go ahead and actually cancel an event and define a new event that does a click event for us. But again, I don't want to spend too much time on this. So I kind of want to just move on to things that are going to be more common with the event system. Just know that you can do that. But more likely the case is you're going to use a lot of the event types that are built in for us. And the one I want to cover is the one that we haven't really looked at, but is super critical. It's the mouse events. So the different types of events that we kind of care about for mouse Inputs are going to be mouse down and mouse up. So this is the mouse button is either clicked or released over an element. Mouse over or mouse out. This is where the mouse pointer comes over or out from an element. We have mouse move. Every time the mouse moves other than over an element, it triggers that event. You have a click, which triggers a mouse down, and then the mouse up over the same element creates a click event. So just like you can have a click event on a button, that's the event that gets generated by mouse down and mouse up. We have a double click, and then context menu is a right click. Okay, so as you can see, there are multiple events that we can trigger, sometimes at the same time. And so event ordering is definitely something you should be familiar with mouse-generated events and keyboard-generated events as well, or just events in general. When you produce a set of actions with your input device that could trigger multiple events. And so what will happen is your callback functions will get invoked in a different set of orderings based off of which events occurred first. So on a mouse click event, there's actually just the ability to capture the mouse down action. There's the ability to capture just the mouse up action. And then the combination of a mouse down and a mouse up action on a button produces a click. So if you had registered event listener for the down, and then the mouse up, so mouse down would register the callback function or invoke the callback function first, followed by the mouse up, then followed by the click. It can get pretty nuanced, I'm sure, but if you ever have issues or erroneous behavior in your code, just do some console logging. And in fact, that's what we'll do right now. We'll do a demo of all the different mouse events. So let's see what we're going to do. We're going to create an input here. In our input, our value is going to just be click me with the right or left mouse button. Okay. So we will bind to the mouse down, the mouse up, the click, the context menu, which is like the right click, the double click. And for each of those, we'll just go ahead and log that event. And what are we doing to log? Well, we're just creating a function that grabs an event object. That event object will display the type. And then we'll go ahead and print out the button that also was a part of that event. So let's see what this looks like in practice. Let's copy this. Let's hop on over, refresh this. Let's go into my document, right, and let's paste this. Perfect. Okay, so I have the shine button. So the first thing I want to do is when I click on that, notice one click generated the mouse down with button 0, a mouse up with button 0, and then a click. Perfect. Let me do a right click. Now notice a right click, mouse down, then context menu, which is the right click action, and then it did the mouse up. And let me see if I can do a double click. Up and double click. I had the mouse up, mouse down. No double click there. I'm not good at double clicking. Oh, there, I finally did double click. Not very good at double clicking, as you can see. But I did get a double click action to trigger. Okay, so let's talk about some of the things we just saw. One of the big things was this concept of a mouse button. So just know that the mouse button that's passed into the event object is going to have one of 5 numerical values. But really, the most common ones are going to be the left button and the right button. But so the left button is 0, the right button is 2. If your mouse has a middle button, that would be 1. And then if you have some kind of X1 or X2 button, like some kind of backward or forward button that's sometimes on mice, that would be 3 and 4. These, I don't think I've ever used this before. I don't usually use this one either. I don't even usually use the right button. But if you do want to have, I don't know, some kind of action that occurs when you right click, then it makes sense to look at the button and be able to check that. Okay, so other things that we might care about is all mouse events also include additional like modifier keys. Like, is the shift key also depressed when you capture your mouse event? Is the alt key pressed? Is the control key pressed? Or is the command key on max pressed? So this will have a state of either true or false inside of your event object. So here, you can actually test this, do a quick demo. Alt Shift click. Okay, so here I would do the Alts, and if I remember correctly, Alts on a Mac is typically, yep, your Options button. So if I do a Option Shift and then click, I should be able to capture this event. So let's clear this. Let's go into my right. Option click. Yay, it worked. It doesn't do that unless I do that button combination. So again, we can listen for key events as well as click events via the event object. So that event object is very useful for us. Another big thing that the event object will give us is the client X and client Y. So obviously the coordinates. A lot of times you might want to drag a object around across the HTML page and change its coordinates. And you can change the coordinates to whatever the mouse coordinates is using the mouse's client X and client Y. And here, I'll just do a quick demo of this. On the document body, I will create a on mouse move method. So as the mouse moves, I will show the new coordinates of where the mouse is currently at because it's given to me in the event objects client X and client Y. So let's go here. Let's do, what is this? That's just JavaScript code, so I don't have to write that to the DOM. Okay, so now you'll see as I move my mouse around, it'll show me what its X and Y is with inside of the viewport. Then I could use that for all sorts of good things in my application. I can prevent my mouse from selecting data. Don't really care about that. If for any reason you're implementing double click and you're having problems with it by default selecting text, you can prevent that, but I don't want to spend too much time with that. Okay, so let's talk about moving the mouse. So we talked about all the click events and click events along with buttons. Let's talk about being able to have the mouse go over or out of and checking the related targets of the events that trigger. So here, let's just jump into the demo because I don't think this needs a lot of descriptions. Here, I'm going to create a div that has an ID of foo. I'll create another div that has an ID of bar. I will access the foo in my JavaScript to assign a on mouse over callback function that will give me the target of the event and then the related target. Now, the related target is going to be, so the events are special because they have a property related target. The property complements target. When a mouse leaves one element for another, one of them becomes a target and the other one becomes the related target. So when you're crossing between two elements, you actually get a reference to both of them. So let's actually see how that can manifest itself. So we will print as we move from one to the other. So let's clear this. Now here, let's do document.write. And okay, so here, the first thing I'm going to do is I have my target would be my bar. The related target was the body, right? Because I moved off the body to target the bar. Now, if I move from bar to foo, notice my new target is foo. The related target is bar because I moved to foo from bar. And now let's see. Oh, and then I moved on to the document object. So, and target foo. So from the document object to foo. So it didn't have a reference, so the default reference was HTML. Okay, then foo, then let's go back to bar. So from bar, so my new target is bar. So my previous target was foo. So this just allows me, when I'm moving the mouse around, to be able to reference the last element my mouse was at and the current element my mouse is at. One thing you should be aware of, though, is that if your mouse moves too quickly, it's not going to catch pixel by pixel every element. There is like a span of time between that the browser's actually polling what element you're over. So just understand that if the cursor goes too fast, it is possible that the related target might be some prior element, and not necessarily. It doesn't happen often. Just understand that that is something that could occur if you have a lot of elements and the user is moving the mouse very fast. Moving out. Okay, so let's talk about the relation between moving out and moving over between a parent and a child. So one important feature about mouse out is that it triggers when the pointer moves from an element to its descendant. So when you move from a parent to a child, then it will trigger the mouse out or the mouse over. And then we can prove this. I don't care about proving this, really. I just want you to understand that if that's not a behavior you want, there's another set of events you can listen for instead, which are called mouse enter and mouse leave. And these trigger when the mouse pointer enters or leaves an element. So the two important differences are that these don't bubble, and these have transitions inside the element to and from, and they're not counted. So if you need a better granularity for descendants, use mouse enter and mouse leave. Otherwise, use mouse out and mouse over. Again, don't want to spend too much time. Just one of the situations that I want to supply you with with the resources. So as you're working on your projects, and if you have erroneous behavior, you can check. Okay, let's move away from mouse events and start talking about keyboard events. Keyboard events, super simple. We've already seen keyboard events. You have two, key down and key up. And when you do key up and key down, you get one of three properties back. You can get so the event object has a key property, a code property, and a key code property. The key would be the actual value that's depicted on the key. So, and it's case sensitive. So if you hit like Shift Z, it'll be uppercase Z in the key the event key. If it's lowercase z, then just be Z, or you just hit Z, it'll be lowercase z. In event code, though, those two would be the same. It would be the Z key. And then the key code is what is the numerical value of the key that got pressed. So this you should be super familiar with a platformer. I will just go and post code similar to what was on the platformer, where we listen for a key up event, and then we'll print the event key, the event code, and the key code, just so that you could see these in practice. So let's just go ahead, add that to the body. So now let me click, focus in on the body. And now if I hit W, notice that's lowercase w, key W, and then the key code of 87. Or I can hit Shift W, which gives me the capital W, still key W, key code 87. And then it also captured the shift click there. Arrow up, arrow down, arrow left, arrow right, space. So in the platformer, if you didn't want to use those key codes because those look like magic numbers, you could have used arrow left, arrow down, and just looked at the event code instead of the event key code, if you wanted those to be a little bit more readable. Okay, I didn't really want to spend too much time with touch. You can just check the API for that. I do want to talk some about the document object and what events a document object. The most critical ones are going to be the load and the unload methods. So essentially, all the events are you have a DOM content loaded. So this is just that the browser loaded the HTML and the DOM tree is built, but this is before your external resources like images have been loaded into the browser. Load is the one we typically use. So this loads all the HTML content into the browser and all its related external resources, such as the styles and the images. So notice when we were building the platformer game, we had a load function. We binded our game start to the load function because we want all of our images to load before we started to try to render them. We can't start rendering content until it's actually been loaded into the browser. And so this is a huge use case for load. So if there's assets, any kind of media assets that are critical for your application, then you want to bind the start of your application to the loading of the document. That's going to be the biggest use case for this event and why you should know about it. You also can actually have an unload event. So this is when the user attempts to leave your page. You can do something in response to that. Unfortunately, this gets used nefariously by a lot of developers to try to refresh you back on the same page. So very unfortunate how they sometimes get used. And one other thing that we have for this is going to be the for our document is going to be the ability to check its state. So we can say we can query the document on what state is it currently in, and there's 3 different states. It's currently loading, it's in an interactive, so the document was fully read, or it's complete, so the document was fully read and all resources are loaded as well. So by default, if I were to go into my console and just type ready state, it'll just show me complete. But here you can actually check the state in your application, and when it changes to a complete state, then you can start certain behaviors. What's a common thing that you'd use for ready state might be, if there's a lot of assets you're loading in, to have some kind of loading display or image appear until your entire content loads up, and then you can display the actual computed results. Okay, let's move on to the form and inputs events. So these are probably the most convenient way of handling events generated by a user, because these are HTML defined events, or these are things we can capture from HTML elements within the DOM. And so their behavior's the same for all devices. One thing you might have noticed is when we talk about mouse events or keyboard events or touch events, these are all kind of specific towards the input mechanism for a device. So like if I'm on my smartphone, I don't really generate keyboard events. If I'm on my laptop, I don't really generate touch events. But if I look for events based off of HTML forms or inputs, it doesn't matter if I'm on a smartphone or if I am on a laptop, I can trigger those events both ways. So for that reason, these are super convenient for our web applications. So one of the first things we should know about our HTML forms is, and our various inputs, is how can we navigate them? Well, we already learned how to access this stuff on the DOM, but I gave some just simple ways. You can always just go ahead and access from the document object, all the forms. So if you embed your inputs in a form, all your forms are immediately available from the HTML collection that the document maintains. So say, for instance, I had this form that had the ID of spam, then I could just access from spam whatever the inputs names are. So notice this isn't necessarily based off of ID when I'm accessing it this way. If I give my input a name, then I can use the name to access it from the form level to read that value. And very similar, every element that is a child of a form can look backwards and get access to the form itself. So say, for instance, I have this element foo, right, which is defined, it's one of the inputs in my form. Well, foo will always have a property called form, which is a reference to the form it's associated with. And then from the form, I can look at other children from form, so I can find its siblings very easily, or find other properties or attributes to find in the form. Okay, so let me just kind of run through what the form and input elements are, because we kind of did this in the DOM, or in basic HTML, not when talking about the DOM, but like on the first or second day of lecture, we covered a lot of these. So form can have input and text areas. I think we've already seen that. You could have select and options. When we were doing the interactive game, we kind of saw all these different options. So our forms have events. The biggest event that we'll probably care about is going to be the focus and blur event. So essentially, focus is an event that occurs when you either click on or when you tab into an HTML element, when a user does, then it triggers an event, a focus event. And when you leave that element, because you either target some other element, then a blur event is triggered for that HTML element. So let's take a look at this in practice. Pretty simple concept. So here, I just create a form. It has the ID of spam. It has an input that's called foo. It has initial value of bar. What I'm going to do here is on focus, I'm going to assign a callback function that will just console log that focus was triggered and what the value of my input was, foo.value. And on a blur event, I will console log that a blur event occurred, and I will also display the value of foo. So let's go here. Let's go to document.write. Perfect. So here, when I click into my bar, okay, you saw that went ahead, or when I click into my input, notice that caused my console log to say, oh, look, a focus event occurred, and the value of my input field is bar. So let me delete that, and now instead replace that with like hello. Now when I click out of that, causes a blur event to occur, and it will show that my value is hello. Okay, so that's just an example of what a focus and blur events are. Let's talk about other events that we can look at on these input forms or input fields. I could check to see if the state, if the value changed on a particular element. So here I have the same thing, a form that is ID to spam. Inside the input, I'll call it foo, and I'll actually give it the ID of foo so I can access it. I'll give it I'll give it the callback function on change. So every time my input changes, so that means the change happens when a blur event triggers. So then it will go ahead and console log a change event or the change message, and then what is the value of foo. So simple couple lines of code. Let's go here into my console and test this out. Let's go ahead and update the DOM. So now I'm going to click into my input here, and I'm going to change that to be hello. And then when I click out, the change event, notice that the value changed after a blur event occurred. It looks for the change, and since there was a change from the previous value, it triggers this change event, and then it which prints out the new value and the message change. But even more powerful than change is input, where input will trigger every time a value has been modified by the user. So this is the exact same code we just looked at. This triggers when the element has finished changing, so when a blur event had occurred. But here, it'll actually monitor for changes even while I'm typing, while focus is still on that input field or that element. So let me go in here. Let me go to document.write. Let's go ahead and update the DOM. Perfect. So now when I click in here, right, I erase the B. Now notice each time I erase something, it's showing me. And now as I continue to type, each time I type something, it's updated inside of the console as I delete. And I think the last thing that I have to talk about with forms and input is going to be the submit event. The submit event is used for the form attributes and form attributes only, and they're used to trigger for a form to get submitted to some back-end web server. So we'll talk more about event submits when we get into asynchronous JavaScript and we start sending data from our client to the web server. But typically that data is sent, or one way to send that data is through a submit event, which is attached to a form itself. And we'll actually have a lab on that. Okay, so the last type of event that I want to talk about, and so I guess I'll pick this up on next Tuesday since it's going to be, since I won't have enough time to really cover this That's such a shame. It's just like 10 slides away from finishing. Well, what I might do, just so I don't have 10 slides, is I might continue to finish this lecture out, and it'll be available on the video for those who can't stay for another 5 minutes to finish this out. But yeah, it's exciting to get this lecture done. So the last event that I want to talk about is time-based events, which are scheduling events. And again, if for any reason that you have to go to another class or whatnot, this will be made as part of the actual video. So it'll be posted, and you'll be able to watch it. Okay, so one of the big events are time events, and they revolve around scheduling. So this allows us to schedule either timeouts or intervals. A timeout allows us to wait some specified amount of time and then trigger our callback function, whereas set interval will repeatedly call our callback function after some duration of time has elapsed. So these are the two most common scheduling events or time-based events that we can add to our dispatch system. And so the syntax to go ahead and set a timeout is the window object, the global object actually has a method called set timeout. We just provided the callback function that we want, and then the amount of time that we wanted to go ahead and wait before invoking that function. So if I go over here, let me refresh. Is this? Oh yeah. And so here, this will wait 1 second. 1 second. So this is in milliseconds. So this will wait 1 second and then call that hello. And so I could do that either with parameters or without parameters. So notice if I needed to pass parameters to my callback function. So here, my callback function say name requires a name, and it's going to console log that name. Then I can do set timeout, pass it a callback function, pass it an amount of time, and then pass it the parameter that I want to provide that callback function. So here, let's test this out and see and prove that this is actually a thing we can do. I will go ahead and after 1 second, it actually prints out foo. And the foo, the name was given as a parameter for set timeout. If for any reason I needed to remove a timeout function, there's a method called clear timeout where I pass it the timer ID. So every time I go ahead and generate or register a callback function into the scheduler, then it generates a timer ID as a return value. So when I call set timeout here and pass it this callback function that's just going to console log that this has never happened, then it gives me this timer ID. And I can actually see the value of the timer ID. In fact, the number here that was given back to me that I wasn't doing anything with was a timer ID given to me from the set timeout, given to me by the scheduler. And so I can then use that timer ID to tell the scheduler to remove that timed event so it doesn't exist anymore. So here I'll just take this code, which will do nothing because I'll create a scheduled event, a timed event, and then I'll immediately cancel it. So here I create a set timeout, I grab the timer ID, I'll print it out, then I will tell the scheduler to clear that timeout so it never occurs. And now, since it's no longer part of the scheduler, the timer ID doesn't exist, so it becomes undefined when I try to console log that again. And very similar to that is set interval with all the same parameters. The only difference is that it will continually invoke the callback function every, in this case, second. So here, if I do this, if I have, say, hi as my callback function, and I set an interval with the callback function say hi every second, it's going to say hello, and after a second, say hello, and another second, and another second, and another second, and indefinitely do that. And I can even do that with parameters, just like I could do with set timeout, exactly the same. Here, I'm printing out foo. Oh, let me stop this too, so it's not just looping that forever. Okay, and just like I could cancel from my scheduler a timeout event or a timeout, yeah, I guess event, I can also cancel out an interval event. So, and when I register an interval, it gives me a timer ID. I can use that timer ID to indicate to the scheduler to clear that interval using that ID. And just like with the set timeout, that timer ID will become undefined when it's no longer part of the event, the time scheduler anymore. So I just want to compare and contrast set timeout with set interval, because it's possible to use set timeout to create nested timeouts, which means that from our method, from our callback method, we can actually call timeout again and get a behavior that's similar to set interval, but more powerful. Because set interval, once you define what the interval time is, it never changes. It's the same 1 second or 5 seconds again and again and again. Whereas if we decide to nest our timeouts, then we can change when we will reinvoke the callback function. So an example of this is, suppose that I create this tick callback function that can take in a parameter. The default value is 0. And we'll take whatever it is and we'll add 1,000 to it. We will console log that a tick occurred and what the current I value is. And then we will then recursively kind of call set timeout with this anonymous function where we're invoking tick with the new value of I, and we're going to pass as the amount of time what the value of I is. So notice when we go and invoke this set timeout with initially 0, it's going to call in 1 second. But then, since the new set timeout is going to increment that to 2,000, it'll be 2 seconds. And then it'll be 3 seconds, and then 4, and then 5. So we can get this really dynamic behavior where we can affect how often the interval changes by nesting set timeout calls as opposed to just using set interval. So here, the point is sometimes it's better to nest this if you want to have a variance. Like I could even do math.random and have a random amount of time that happens between invocations. So let's do NC tick was 1 second, then 2 after 2 seconds, then 3, then takes a little bit longer, 4 seconds, then a little bit longer to get tick 5 seconds, and then a little bit longer to get tick 6 seconds or 6,000 milliseconds. So it gives you a good idea of how we can get a behavior like set interval with set timeout, but it gives us more control. And the last of these timed events that I just need to talk about is the one that I think we actually used in the platformer game, and it's the request animation frame. And so request animation frame, we don't control what the time is. This is something the browser does. So typically, what the rule of thumb is, if it's data that you're processing on, you use set timeout or set interval. But if it's anything that's designed to be rendered to the viewport, then let the viewport decide when the appropriate time to recall, when to redraw the graphics. And so that's when you want to use request animation frame. So it's just a function to execute the next closest time the browser wants to redisplay the viewport, so that it's more consistent in how it looks. So this is usually used obviously for animations, and so that's what we use it for in our platformer game. So here I'll just run a quick example of this, and we'll update the DOM. In this example, I'll create a callback function that's called say hi. It will, on the document's body, append to the inner HTML hello and then a break, and then it will invoke this function again with a request animation frame. So this will recursively keep calling itself, and then we'll initially call it here with a request animation frame. And so again, just like with the time ID, the request animation frames also give us a time ID or a request ID that we can then also cancel that animation frame with. So let's just test this out, and then we'll look at the last slide and then be done. So here, yep, we see we displayed lots of hellos, And here, the only parameter we had to send it was the callback function, and the browser decides when it's appropriate to refresh the viewport. And so we can use that request ID that we got there to also cancel an animation frame. And when we do that, it will have never occurred, just like when we canceled a timed event. So here, just to show, never actually writes. So that's the same code, but we do a cancel before it ever does a refresh. And that's it. We covered all of the event-driven concepts in JavaScript in today's lecture. So perfect. It'll be great for reviewing material to be able to just have it defined on one lecture. So I'll post these slides onto Moodle, and I'll post this video onto Moodle in about an hour or two as it becomes available. Anyway, with that said, for those of you who were able to have an opportunity to stay, is there any questions in terms of the concepts that we talked about? So at this point, we did a very deep dive on everything related to the browser side APIs. So we really looked extensively at the DOM, and we've really looked extensively at the event loop and how events are generated from the keyboard and the mouse and from the document and from forms, and even how to do timed events between the event dispatcher and the scheduler. So I think we're really good to build any front-end application at this point that can just run as its own kind of inclusive piece of software. It's not networked yet. We didn't talk anything about how to get new data from web servers, but at this point, you should be able to build any kind of application that runs in a browser. So is this making sense for most of y'all between the labs and these lectures? Are you guys feeling comfortable with Excellent. Okay, well, I will stop. If there's no questions, then I will. Excellent. So if there's no questions, I'll go ahead and stop the recording for today. And I guess have a great weekend. I'll be working on a new lab, and I'll try to get that available as soon as possible. And so we'll pick up next lecture probably with asynchronous JavaScript. We'll be able to move on to asynchronous JavaScript next Tuesday, which is perfect. That's right where I want to be at.